Alright, welcome to another interesting video, and today we want to look at empirical and molecular formula. A hydrocarbon consists of 92.3% of carbon. If the vapor density is 39, determine the molecular formula given that H is equal to 1 and C is equal to 12. Now, we want to find the molecular formula, but we have to find the empirical formula before we can find the molecular formula. So let's go straight to that. So we have to find the empirical formula. So let's find the empirical formula first. Let's find the empirical formula. And how do we do that? We are told that carbon has a percentage of 92.3%, but we are not given the percentage of hydrogen. Now, we understand that the carbon and hydrogen combined will have 100%. So for us to get the percent of hydrogen, what do? We do what? 100 minus what? 92.3. That's going to give us what? 7.7%. So the percentage of hydrogen is 7.7%. All right, it's 7.7%. Now we can move straight to finding the empirical formula. So let's continue. So how do we do it? We put carbon here, we put hydrogen here. All right, so hydrogen is 92.3% by mass, and carbon is 92.3% by mass, and hydrogen is 7.7% by mass. So what do we do? How do we find the empirical formula? We divide by their masses, all right? So this becomes, the mass of carbon is 12, the mass of hydrogen is what? 1. 92.3 divided by 12 is going to give us 7.7, and 7.7 divided by 1 is still going to give us 7.7. Now we are going to divide by the list of them. Now they are actually the same thing, so we have no choice but to divide again by them. Now the normal way is we divide, when we divide this and we get this, we divide this and this with the least of them. That's the smallest of them. But since they are the same, we have to still divide by 7.7 again. All right. So 7.7 divided by 7 gives us 1 ratio. 7.7 will also give us 1. So it means that the empirical formula, all right, since this is 1 and this is 1, is going to be what? C1H1. But C1 is the same thing, H1 is the same thing as writing CH. All right. Now let's move on to getting the molecular formula. All right. Let's move on to get the molecular formula. Now, for us to get the molecular formula, we need the mass of the compound, the molecular mass of the compound. But in this question, they said if the vapor density is 39. Now, the vapor density is 39, but we can get the molecular mass. Now, I want you to know that molecular mass is vapor density times 2. All right, molecular mass is vapor density, so the molecular mass is going to be equal to what? The vapor density is given to us as what? As 39. So this is going to be what? 39 times 2. So molecular mass is going to be equal to 39 times 2. That gives us 78. Now we can now find the molecular formula. So what do? Our empirical formula is CH. So it becomes CH into N must be equal to 78. All right. You say CH, that's your empirical formula, times N, the number, is equal to 78. Now, what's the mass of your carbon? 12. Plus, what's the mass of hydrogen? 1. Times what? The N. All right, is equal to what? 78. All right. Now, 12 plus 1 gives us 13. 13 times N, that we have 13N is equal to 78. But we are looking for N, all right? So we divide both sides by what? 13. So you divide both sides by 13, you have N is equal to 78 over 13. N is going to be equal to 78 over 13 is going to give us what? 6. All right. So therefore, our molecular formula now is going to be what? Come and put the value of your N, which is 6 here. So if you put it here, you have CH all into 6. So it becomes what? 6 multiplied with 0, you have C6H6. All right. You have C6H6. So this is going to be your molecular formula, and this is your what? Empirical formula. So that's how to get the molecular formula and empirical formula of a compound. Make sure you like this video, share this video, and hit the notification button after you subscribe. Make sure you subscribe. Do not forget, Jesus loves you. Thank you.